Hope you guys are doing well. So, continuing our journey with design patterns, now would be learning something called as state pattern, right? And we'll see like how is this pattern related. Okay, so again, let's see a real world example. Then we'll try to debug and check how our state pattern is solving the issue. For example, we have a music player. We have two possible states, right? Either it could be playing or either it could be paused. So you have two states, playing and pause, right? That could be Either it could be playing, uh, or it could be paused, right? So what we need to do is, based on the state, we need to change the functionality, right? For example, if the music is playing, then we need to do something, and if it's paused, then we need to do something, right? So what is going to happen is, this basics. If you do it in a normal way, you will be using a lot. We'll be using more number of if and else, right? So to avoid this, we use a state pattern. Now, what the state pattern says is instead of so once we start using if else, we are going to fall into the issue of we are going to violate the open close principle, right? And even your SRP is also getting violated. So this is what I mean to say. Let's say, okay, let's have this as medium small. This is Let's change this to XN. Make this small. Let's increase the size of the box now. Let's increase it so that this code is. So this is the two possible states that we have, right? One is playing and one is pause. So now, based on the state change, based on this state, we are going to form some functions, and then we are going to do something, right? Now, so this if else ladder is what is going to violate our open close, and your SRP is also getting violated, right? You have multiple functions present in here, so a single class should have only one functionality. So now what we are going to do is, so instead of this, we are going to break it down, right? So what we are going to do is, we are going to have an interface, and then we are going to have two methods in it, right? So whatever or whoever is present implementing this interface will have to implement the contract as well, right? So if you make this, so whatever method is going to implement this, the contract has to be implemented by that as well, right? Now, but then the problem that is going to happen is here is, um, see, whatever, I mean, but isn't this violating lead curve substitution? Because again, like an interface segregation is also not happening, right? Mm, but doesn't it violate interface segregation? Uh, uh, like doesn't the state pattern violate my interface segregation? Mm, But then whatever class is going to implement it, so instead of having one state, you're going to have many states, right? Now, how are we going to solve that if else problem? So the way we solve that if else problem is basically, um, so we were stuck in that if else issue, right? So to resolve that if else ladder, what we do is, so um we kind of interface, we'll have to implement this state, right? So whatever the class is going to implement, um okay, so we're implementing this state, and then where is, what this is going to contain is an object of music player class, right? Like we are going to pass the instance in that, and this instance is going to, so we are creating the object here, new playing set state. How is this working? So we are going to create the context class, and then public music player this dot state. No, there's something. Hmm. So I have this interface, and then this is, so if you see this, I need to somehow set the state here, right? The state has to change, and that is present in this music player class, but I don't need this logic right now. We need to take that context class out, and instead what we are going to do this, so we are going, so this two is going to come in our interface, so I have to, so we need to update this class state as well right now. If this is called, is that what is happening here? So I have okay, so first is there is something that needs to keep a track of the state, so this state is present here, and we have taken these things two out, and so there are going to be separate classes who are going to implement, right? If I have a playing state, and then I have stop state, right? But then this implements is, oh yeah, I'm going to implement this state, right? So I can have three possible classes here. One, it could be start, stop, and then pause. So all of them are going to implement it. Okay, that is what I've got. But then how is the state good? So based on that state, change the corresponding class needs to be called, right? I'm going to create an, so when I do a press play, I'm going to call um So from the context class, so based on the state, I'm going to call the corresponding interface which is implementing, right? If I do press dot play, then what is the state change that is happening? When it stopped pressing, uh, pressing play starts the music. When it's playing, pressing pause should pause the music, and when it's paused, pressing play should resume. So there are three states through which our music player is going to go. Okay, so that means when we call the play button, so then when we are this press play, okay, this is the main class, right? So then when I call the press play, what should I do is I should start playing. So when it stopped, then pressing play shall start the music. So if my previous state was stopped, then pressing, okay, so there is this trivial thing is there, right? Okay, so let's see, let's take an example, right? So this is our music player. For example, if you have three possible options in a music player, right? The previous state is going to matter when it is going to reach, oh, like much like a state machine, right? So if this is my also the whole problem that occurs in a state machine is you go through that if else loop, right? If there is no op, oh, I guess. So the previous state is stopped, so I'm going to have two things here. I need to check the previous state, and then based on the previous state I need to do the next thing, right? What's going to happen? Oh, so this is my music player. Now I can have three things here. When it stopped, it stopped. um, so if my previous state is stopped, my previous state is stopped, then pressing play should start the music. Now when my previous state is going to be playing should continue. Pressing pause should pause it. Pressing pause should pause the music. And when my previous state is, say, paused, playing the pause should start the music, right? Paused. So I need to keep a track of this thing. So pressing play now should resume memories. Pressing play should resume music. So now these are the three possible states that I'm going through, right? So what I'm going to do is first is I'm going to check first is basically I'm going to check if I have a previous state, right? I need to be very careful of that previous state thing. Okay, so if in my if else logic, what am I doing here is, okay, if state dot equals stop. So then in my play as well, I have two three conditions, right? If only I enter the stop, then I should be playing the music. If then I should make the state change as well to prove playing. As if my it's paused, then I have to make the state as playing. If it's playing, when I press the pause, so for play I have two possible options, right? Either I could stop it. Oh yeah. Okay, yeah, I got it now. What it's trying to say. So basically, the whole problem in this thing is that we need to get rid of this if else, right? Somehow. Similar in 18, okay. So in state, this is like a state machine thing. Okay, so this is basically no. So basically, what we are doing here is Yeah, this is like state machine thing. And basically in state machine thing you have different states, right? That goes through. So in C, if you see the code, right, it will be a sequence of if and else. But whenever you try to implement the same thing, but then too much if else is going to break that open close problem, right? Because if I try to add a new thing, it should not be able to modify the code. But then this becomes able to modification, right? We shouldn't be able to do that. However, we should still be able to add the new thing. Like we should be able to extend it and add the new one. Okay. Then how is this related to? How is this going to be the problem with? So even in if you see in JavaScript promise as well, there are three states, right? Pending, fulfilled, and resolved, or pending, fulfilled, and rejected. So the because this is having the state, so we are going to have that three states. Based on the three states is what we are going to do something. Oh, I see. Because we have three states, the state pattern. Yeah, we have three straight transitions, right? Either I could have pending state or fulfilled state or rejected state, right? So resolve is going to be my fulfilled. Reject is going to change the thing to rejected, right? Okay. Then the next pattern that we have is something called as okay, so then we have something called as command design pattern, right? Let's see that like what is that doing? So basically in command pattern what we are going to do is, for example, basically we are going to command pattern turns a request into a standalone object, allowing us to queue, log, or undo redo operations, decouple the sender of a request from its receiver. In simple words, wrap an action in an object so it can be executed later, passed or around, or be undone. Understanding how um, promise class. Let's see the class object. I have the promise class here. Okay, let's copy this and then let's try to understand how we are going to. Okay. Okay, so this is my constructor, right? This is my promise constructor that is present here. So initially, what is going the moment I call that promise or I create an object of this promise class, what is going to happen is my state is going to be in. I'm going to go in the pending state, right? And then my value is going to be undefined, and then I'm going to. So these are basically for the observer, right? For then and for catch to call back when you get. Okay, so this is for that observer of then and catch. Now when I do a resolve, so when I am going to say resolve, so what I'm going to do is I'm going to change the state from pending to fulfilled. Here I'm doing two things. Either I'm changing the state, and then similarly when I go to reject, I'm doing two things. One is I'm going to change the state to be rejected. Okay, and then I'm trying to do something. Now, what is this executor? That is something we need to study. Then, so this, okay, yeah, we need to study executor in. So in the constructor, I'm passing this executor, right? So this is basically a synchronous function. He's saying the executor is a function you pass to the promise constructor. It runs immediately and receives two arguments. Then okay, let's come back to okay. This is my executor. I have it receives results and reject, right? Uh, I'm going to do this try catch. Okay, wait. So try. So if I get an error, then I'm going to. I'm inside this block, right? The executor runs synchronously immediately upon the creation. Inside it, you perform an async task like set timeout, fetch, etc. You can't call resolve or reject error. When done, the promise transitions from pending to either fulfill or rejected. Okay, so what is going to happen? So I'm going to have this. Okay. So I have. So in the constructor, I need to pass the executor, right? So the executor will take in two functions, resolve and reject. And then Now, what is the use of this try catch block here? If this, okay, so always the initial state should be pending, right? And then I'm going to change the state. And this dot successful callbacks for each. Okay, so this dot successful callbacks is basically what is what are we storing in here? Okay, let's see what is present here. Oh, so basically it is going to store all my dot then callback. So inside then I pass a callback, right? So success callbacks is going to store all the dot then callbacks registered on the promise. And okay. So this executor is going to take into parameters resolve or reject. This is my resolve thing. I come here for okay. So for my resolve, I'm going to resolve this, and then for my reject, I'm going to reject it. I'm going to do if state not equal to okay. First, I'm going to check that whether I'm in pending or not, because initial state will be always pending. Then I need to modify. I'm modifying this state, right? Okay, then I'm going to loop over through this and call the callback. So this is basically like this is going to get called, right? So this is an so what is going to be passed in parameter is the element present here, and then CB of reason. Now what is this? This is my return value, I guess. So whatever is returned by this, so uh, okay, the reason is this failure. Okay, yeah, I get what he's trying to say. So you are going to store this function, right? The callback function, and that callback function takes in whatever we the dot then method whatever is passed right inside that way. And no, so I'm going to loop through all the elements in this success callback. Okay, and then when I do a resolve, basically is when I'm going to have that value being passed in here, right? uh Okay, I'm using promise to do a sync operation. Okay, suppose I'm doing a set timeout, right? Okay. Now what I'm going to do is, so this is the move. Okay, this is that executor that needs to be passed, and I need to perform the sync operation in the executor, right? Because this function will be called immediately, and then so I'm going to do my set timeout here. So I'm basically going to wait till 2000 minutes, and then um and I'm going to wait for that time. Okay, I'm waiting for that time, and then the first is basically okay. This function needs to be, so how will this function be called as uh, okay, so this fetch data is going to call this thing, and then in the first line itself I'm going to return a new promise, right? I have a new promise object which is being returned, and then I'm going to, so this is going to get immediately called in, so I'm going to have console log the fetching data. This thing is going to be printed. I'm going to wait for 2000 seconds, and then I'm going to do a resolve. So whatever is present in resolve is going to be passed into this then method, and then I'm going to console.log user received, and then this user, right? Um, then I'm going to say dot catch. So what if when I do a reject here? So then I'm going to do and come here. So internally, how is this linking happening? Is you can see it from here. Okay. Now this then is okay. This is my then and catch, right? And then okay, I'm going to have so this it takes into okay. This is my constructor. So is my from here. Okay, this is the constructor ending, right? This entire block is my constructor. Okay, so then I'm going to uh, this is it's quite complicated thing. So that this the success callback is going to uh, so resolve and reject, right? Okay. What is this callback and reject? I'm still not able to understand. This why do I have the success callbacks? Why do we have the callbacks? Oh no, not in. No, what is. I mean, what is this callback? Okay, so the async operation is waiting for that state to change. Oh, okay. Now, what is this callback queue storing though? Hmm. Set up a place to store a dot catch functions. Based on the state we are calling the callback, something like that. The way the promise is supposed to work is we are going to store that callbacks. We are not going to. So based on the state is what we are going to do, right? So if it's pending, then we are just going to. Uh, so initially everything is going to be in the pending state, right? The moment we hit this, we are going to store the callbacks. Or like this is how the synchronous behavior is kicking in, right? We are not going to loop through. The state is rejected, then run failure callbacks. Oh, I see what's happening here. Oh, so based on okay, let's see. Now here we are basically doing three things. First is which state we are going to change the object's internal state. So that is we are going to loop through this pending, like a state machine, like fulfilled and rejected, right? We are going to do three. Sorry, yeah, we are going to change the state. Then we are going to change the behavior, right? So for example, this is like an observer pattern. Okay, let's see the observer pattern, right? So the observer pattern has two things, right? For example, if there's any new video coming, the notification has to be sent, right? So on similar lines, if I get a dot then thing, if I get a fulfilled promise, then I'm going to so these will be initially stored, like they are not going to be executed. These callbacks are what is going to be present in the queues. Okay, it's making sense now a little bit. I guess what is happening is here is um, okay, and when I'm creating the object, what am I passing? Okay, this is the executor itself takes in two things: a function and a reject. Also, by this reject thing, what I'm making sure is um, you will get one stage mandatorily, right? Oh, so this is this. So what this? So if you see this executor function call is basic. The first parameter is nothing but a function that is being. So the executor takes in two things: a resolve, a reject, and function. No, this executor is going to work in synchronously. This is not going to. Wait, just let me. Okay, this is the function call to the executor, right? So the executor has resolve reject, right? Oh, this executor is what is controlling that thing. So does the executor take in any function? Okay, this has to be a function that takes in two parameters, resolve and reject. Okay. Why am I? Is this calling the executor? So whatever I pass in my constructor goes. Okay. Am I doing something like what do you say? Is this does this like um I feel it's doing that thing on fly. Okay. I sign to an anonymous. Uh okay, so this entire function is going to get uh for example, if I have this callback and then when I call it from yeah, this is a function, right? So now this callback is basically what I'm calling. Okay. Now what if the fun oh, because it has those parameters being passed, right? I'm going to call using the parameters being present there. Oh yeah, that's what is happening. This function, oh, now this greet is getting assigned to callback. So callback has basically just calling in that resolve and reject. Okay, okay, I see. Okay, so we'll see a little bit more in detail, like the state and context pattern, and we'll try to understand more about what. So state is basically like controlling that state thing, but then and then we are going to get rid of that if else logic, right? Basically, but then if you see here, this code is still does not. We still have this if else thing. Oh, but see now what have we done is we have separated something here. Uh, okay, let's see. If you see that class in detail, uh, mm, the open close, then there is okay. No, do you follow the core idea? It's following the core idea that it's doing procedural state management rather than performing polymorphism, right? It's not actually based on um, so now when we come back to our, there is one famous question on promises, right? No, we can get click on. Oh yeah, let's click on sign in. And let's come to, okay, let's yeah, okay. Yeah, it's as simple as that, right? Okay, so basically, like this is how the promise class looks like, right? So what we will be storing here is we'll be all storing all the then callbacks, and we'll be waiting for the state change to happen. The moment we do the state change, we are going to pop out callbacks one by one. I see. So inherently, this executor is going to run synchronously. So then, so if the executor is running synchronously, it's the thing written inside the executor is what making it wait. Is the async thing, right? But inherently promises by will because this executor is running synchronously. So uh, the thing written inside the executor is what promises is what making the promise to be uh what do you say is what making the async logic to happen. But the executor itself is synchronous. So if we write a sync code, if we write a sync code inside the executor, then it will not be sync. Oh, so yeah, it's so even in callbacks are inherently synchronous. Is the what do you say? Is the um the thing is this callback? It's not put in this success callback. It's kind of put in the microtask queue. That is why that also this successful call. Okay, the microtask queue and this dot success callback. Okay, this is our own version, but then here you won't be having. So internally, this is related to the microtask queue. So internally, we are not putting it in a normal queue. This is present in a microtask queue. This is microtask. So the that is how they even if I have a synchronous code written inside the executor, still the then method will run only when you have you will be able to consume the promise only when the microtask queue is scheduled. So even though you have um, so inherently it becomes asynchronous. Okay, even though you can write Async. So even if it we write synchronous code, inherently this is not a normal queue. It will be a microtask queue. Still, it will be running um, by default. Then since we say that by default promise is related to async code, right? Async in nature. Yeah, promises are going to be asynchronous in nature. It's because of the way dot and callbacks are stored. They are not stored in the normal queue. They are stored in the microtask queue. That is how Node or any other engine stores or handles promises. Oh. So I guess yeah, that's all for this lecture. I'll see you guys in the next one. Till that time, take care. Bye bye. We'll see a little bit more about state and maybe context pattern in a little bit detail, and then we'll try to cover as many as behavioral patterns as possible. Thank. That's all for this lecture. I'll see you guys in the next one. Till that time, take care. Bye bye.